I have created this problem in a way so that the resultant acts outside of the beam, which may sometimes surprise you. You might be thinking you probably had something wrong somewhere. It's not. So the resultant may come, the location of the force may come outside of the beam. It is possible. So let's do the calculation and see what we find. So here, for example, to calculate the resultant, we'll have to resolve this force in y direction. So that's going to be 50 sine 60 degree. And the horizontal component would be to the left direction, which is 50 cosine 60 degree. So the total force in x direction is simply this. So cosine 60 half, so that's going to be 25 pounds, which is negative to the left direction, 25 pounds. And then the summation of Fy, the total y forces coming externally, is that plus positive 50 sine 60 degree and then minus 100 pounds going downward. So that's the all external load coming. I calculated that. I think it was 50. Let me check my numbers. It was 56.7, also negative. So this 50 sine 60 is actually 43.3 minus 100. So that's going to give us 56.7 pound in the y direction. So that's the total force in y direction as the total force in x direction. I can draw a quick figure here. So here 25 pounds, here 56.7 pounds. So the resultant will act somewhere towards this way. So that will be the resultant. Let's say this is the angle theta where the resultant is going to act. So to calculate the total resultant force simply is going to be we can apply the Pythagorean theorem, fx square plus fy square. That will give us the total resultant force minus 25 is square plus minus 56.7 is square. The minus plus will not affect here. However, I would like to be consistent so that it doesn't create additional load in my brain, which I want to save for the future next step for the problem. So this is the resultant. And then the angle, the direction, we can simply do tan theta is equal to, we can draw a simple line like this, develop like this. So that's 57. So that would be simply the opposite, 56.7, opposite by adjacent, 25 pounds. They're actually 25, look like a 15. So theta I calculated 66.2 degree. So it's gonna go to the left downward direction. We also need to find out now, the surprising piece is the location of this force. We don't know which way it's going to act. I'm going to assume simply somewhere in the middle. Typically, you think, that's probably the most logical way of thinking, that assuming it's going to act somewhere in the middle of these two forces, which we'll find out is not. So to calculate the location, we'll have to apply that Varignon theorem, which states that all the component force moments will be the same as the resultant force moment. So if we do the summation of moment counterclockwise, positive, everything sum to zero. Instead, in this case, it's going to be all component moment will be same as the moment due to the resultant force. So if we take moments with respect to A, for example, positive moment, so that will be, so the component moment for this 25 pound passing through A will not cause any moment. That 43 pound, the vertical component of the 50 pound, will do a positive moment, counterclockwise moment. So 43.3 times the distance 5
And then the 100-pound will do a clockwise moment. So that's going to be negative 100 times the distance, 5 plus 15 from A. And then that will be exact same as the moment coming from the resultant. So if you look at the resultant, the x component will pass through x. It's not going to cause anything. The y component, which is 56.7, will cause actually a clockwise moment. So that will be a negative 56.7 times the distance we don't know, we try to find out. So that's D we're going to calculate. I calculated that the D is 31.46 feet from point A. If you do the same thing, if you take the moment with respect to B, I calculated, so this is from A. If you do the same thing with respect to B, I found that negative 1.46 feet. So you notice this beam is only 30 feet from A. The distance we calculated is actually 31.5 approximately. So it is somewhere here. So the resultant force is actually acting somewhere outside of the beam, which is a kind of surprise. So this is 1.46 from B outside. So so don't get surprised if it comes outside. I change this number in a couple of ways. So in one, I change this 50 pound to 200 pounds, and then this gets even surprising result. So if this 50 pound changes to 200 pound, it actually, the resultant goes to the left side somewhere about 15.5 feet away to the left. So this is where actually the resultant goes, resultant force right here, act here. If I change this 50 to 200 and keeping this 100 constant. So if you find something surprising like this going outside of the beam, which is okay. You can check the calculation again, but don't get surprised if the resultant come outside of the load. It is possible.